purpose of this video is to show you how to work problem number 4 on energy conservation with rotation word problems. And again, this isn't so much energy conservation, but to get you used to working with rotational energy as one of our forms of energy. So I want the total kinetic energy. So the total kinetic energy, we have a formula right up here, is just my rotational energy plus my linear energy. So we need to figure out what both of those are. So I have a solid disk that's 21 kilograms. So I know if I'm going to do rotational, I'm going to have to find I. It's a solid disk. Solid disk is over here. It's 1/2 mr squared. So my I is going to be 1/2 mr squared. And they give me the radius to give me mass, so that's simple. That's 1/2 times 21 times 0.85 squared. So that equals 7.6 kilograms per meters squared. So from that, I also need to find my rotational kinetic energy. It's right here. That's 1/2 I, which I found, times omega squared, and they gave me my omega. Okay, my omega is right here. So my KE is 1/2 I, which I just found, times omega squared. So that's 1/2 times my times my 7.6 times my 15 squared. And that turns out to be equal to 855 joules. I probably should put ROT here so I know that's my rotational. To find my linear, which is just my plain old kinetic energy, I have the mass. I need the velocity, but they don't give me velocity. They give me angular. So I'm going to have to go up and use this formula right here, that my velocity equals my radius times my angular. So that's going to equal my R, which we said was 0.85, times my angular, which was 15. That turns out to be 12.8 meters per second. So now I can find my KE. Which is 1/2 my mass times my velocity squared. So that equals 1/2 my mass, again, was 21, and my velocity is 12.8 squared, and that turns out to equal 1,720 joules. So in this case, I have more linear kinetic energy than rotational, and I probably should put linear on there. So my total kinetic energy is my linear. I changed the order up here. It doesn't matter what order you put it in. Plus my rotational. So that equals my linear was 1720. My rotational was 855. So that adds up to be 2,575 joules. And that's how you do problem number 4.